Today we're looking at using law of sines to solve oblique triangles. So first off, what does it mean to solve a triangle? Find the missing parts. So find the missing angles and find the missing sides. Second thing is it says oblique triangles. Anybody know what an oblique triangle is? There is an oblique muscle, I give you that. But what is an oblique triangle? Any thoughts on an oblique triangle, Kathleen?
I know it has at least one side that's over 90, more than 90 degrees.
You're close. It does have something to do with 90. And does it have to have one over 90? An oblique triangle is a triangle that does not have a 90-degree angle. That's what an oblique triangle is. An oblique triangle is a triangle that does not have a 90-degree angle. So it's not guaranteed to have an angle over 90 because I could have a 60-60-60 and it would be an oblique triangle. So it's just a triangle that does not have a 90-degree angle. So, but before we solved triangles, what type of triangles did we solve? We solved right triangles. Alright, so we use right triangle trig to solve right triangles. Today we're looking at oblique triangles, and one method in solving oblique triangles is law of sines. Now, their law of sines is presented in two different ways, so write these two down for me. Okay, this is one way it is presented. A over sine of A equals B over sine of B equals C over sine of C. And the other way is sine of A over A equals sine of B over B equals sine of C over C. And again, what do uppercase letters represent?
Angles.
Angles, and lowercase letters represent sides. Now, when you use law of sines, you're only going to use two of the three. Okay, so it's just all this is saying is that each one of these is equal to each other. So when I actually use the law of sines, I'm only going to be using two of the three. So I might use the first two. I might use the first one and the last one, and so on. Okay, but we show it this way so that you know that all three of these things are equal to each other when you're dealing with a triangle. Now, we use the top form whenever we are solving for sides, and we use the bottom one whenever we're solving for angles. So whenever we're looking for a side, we want to use it when it's in the top form. Whenever we're looking for an angle, we want to use it when it's in the bottom form. All right. Now, law of sines. There are two types of information they're going to give you if you're going to be able to use law of sines. The first type is they're going to give me two angles and one side. Two angles and one side, and that's the scenario we're going to be dealing with today. It's two angles and one side. They're going to give me two angles and one side of a triangle. We're going to find the missing angle and the two sides. The other one, that's a little bit more, has a little bit more work into it, is when we have one angle and we have two sides, and one of those sides is a match. One angle and two sides, and one of those sides is a match. What do I mean by a match, do you think?
They're the same.
What do you mean the same?
Like-
Same.
I was talking. That was it. I mean,
They're the same. All
Or
right.
is it like is it A over sine A? Like they're a match, they go together.
All right. So what I mean by a match is that I have an angle and its side. So what I mean by a match is I would have angle B and I would also have side B. Okay, that's what I mean by a match. So when they're given one angle and two sides, and one of those sides matches the angle, that's what I mean by a match. And we're going to get to that tomorrow. But today we're going to mainly deal with two angles and one side. Okay, which is the less involved of the two. So we're going to do 3 examples. Here's the first one. Alright, angle A equals 94 degrees. Angle B equals 33 degrees. Side A equals 15. We want to find the missing angle and the missing two sides. So that means I need angle C, I need side B, and I need side C. So, of those 3, what's the easiest to find? Angle C. What do I do to get angle C? Add and subtract. So 94 plus 33 is 127. So what does that give me? 53? So this
Yeah.
missing angle would be 53 degrees. Okay, next I want to choose which side I want to solve for, and it does not make a difference which side I solve for first. Okay, so let's go ahead and solve for B. So if I want to find B, what do you think I need? What do I need to set up?
trig function. B
Alright.
over sine.
B over sine of B. I need B over sine of B. And what do I want that to be equal to?
A
15 over
A over sine of A. Why A over sine of A?
because you don't have C over sine C.
Because I don't have C and C. I've got A and A. Okay, so the other part has to be the match that you have. So my match is the A match. So that's what I need. So let's go ahead and fill out what we know. So we know B over sine of 33 equals 15 over sine of 94. Then what do I want to do to solve for B? Multiply, so 15 sine of 33 over sine of 94. And now we're ready for our calculator. Alright, what do we want to make sure of first on our calculator? If you want to be in the right mode, and why are we choosing degrees, Bailey? We have angles that are in degrees, so that means we want to be in degree mode. So how do I check my mode again?
Menu 5.
Settings, document settings, and make sure we're in degrees. After we choose degrees, what do we want to do? Click make default down there at the bottom.
So if we have a problem in radians, we click radian. Like, will we have a problem in radians for this?
Not with law of sines, no. It's going to be in A. It's going to be in degrees. So we want a new document, and we want it to be a calculator. So what's the best thing to do first to put something like this in my calculator? The what? The ND? Is that what you said? What does that mean? What's that?
So, where you make it where you can input it as a fraction,
Alright, and what's that key combination?
control divide.
Control divide. So the top part needs to be 15 sine of 33. So 15 sine of 33. And the bottom part needs to be sine of 94. I press enter. That side, how many decimals do I want? 3. 8.198. 8.198 is what that side is.
Wait, 490.
Oh, did I say it right? Oh. I have issues. Thank you.
He's gonna go home with
Alright, so now I want to find side C. What needs to change to be able to find side C?
C instead of A.
Instead of B.
There we go. I want to get rid of the B. Okay? Because on the last one I was solving for B. Now I want to solve for C. So that means I'm going to replace my B's with C's.
Yeah.
So I take this out. And I put C's in there. So C over sine of C. So C is what I'm looking for. I do sine of 53. And that means I put 53 right there. So what's the only thing that changed in my fraction? The top angle is the only thing that changed. So what can I do on my calculator since the only thing that changes is my top angle?
You go back up. It's like
Go back up and select it and then do what? Change 33 and change it to what? What do we want to change to? 53? Press enter and that gives me 12.008.
This is what
So I get 12.008 for side C of the triangle. Did I write that one down right, Bob?
you're flying.
Yeah.
Did I write that one down right?
Oh,
Questions on that one?
This is a 10.22. Oh my gosh, it's so much easier than what we were doing.
Alright, let's try another one. Okay, on this one I have angle B is 58 degrees, angle C is 83 degrees, and side A is 9. So that means I'm interested in finding angle A, side B, and side C. Gauge, what would angle A be?
Angle A would be 180 minus B and C added, so 141, that would be something like 39.
39 is correct. Very good. Okay, so I added those two together. I subtracted 180. That told me that angle A had to be 39 degrees. All right, so now I'm ready for, let's go ahead and do B. So that means since I'm solving for B, it's got to be in the numerator. What does it need to be over?
Sine of 58.
Sine of 58. Okay, what does the fraction on the other side need to be?
You're going to use A because you know it.
I'm going to use A because I have a match for A. So that means 9 has to be on top, and sine of 39 has to be on bottom. So then the only thing that has to move is the sine. So 9 sine of 58 over sine of 39. So I need a control divide. I have 9 sine of 58 on the top. And on the bottom I have sine of 39. Press enter. 12.128.
Yeah.
12.128 for side B. And what needs to change to find side C? 58 needs to change to what? 83. So I go to my calculator, I go up, I replace 58 with 83, press enter, 14.194. Now, something we didn't talk about on the first problem is what's a quick way to tell whether or not my answers are reasonable. Okay, I think what Sky is trying to say is that my biggest angle must have the
Biggest number.
biggest side. So what is my biggest angle? C is my biggest angle, so that means side C needs to be the largest. Is side C the largest?
It is.
Okay, what is my smallest angle? A, which means side A needs to be the shortest, and side A is the shortest, so that means my answers are at least reasonable. Question on that. Alright, in your book, look at number 57. Alright, so on 299, let's look at 57.
Exactly.
Says the bearing from the South Bay Lighthouse to the Steep Rock Lighthouse, 25 miles away, is north 28 degrees east. A small boat in distress spotted off the coast by each lighthouse has a bearing of north 50 degrees west from South Bay and south 80 degrees west from Steep Rock. How far is each tower from the boat? Okay. So I'm not real interested in you guys knowing how to handle a bearing. Okay, I'm just wanting you to be able to look at this, and be able to solve the problem they're looking for. So, what is it they want us to find?
The boat.
What about the boat?
The lighthouse.
All right, so the distance of the boat to each tower. So I want to know these two distances is what I want to know. So what do you think is going to help me? What can I do that's going to help me solve this problem? Right, I want to go ahead and label the triangle is what I want to do. So let's say that's A, let's say this is B, and let's say that's C. So now that we've labeled those angles, let's label the sides. So what does this top side need to be labeled as?
B.
B. How do I know it's B?
Opposite
It's opposite of angle B. Alright, so what is this side on the left? C, and that means the side on the right is A. Alright, so let's start with the angles. My three angles. Do I know any of my three angles? Angle B, what's angle B? 78. Okay, and then Bailey, you mentioned angle C. What would angle C be?
52.
Would you say it was, Kathleen?
52.
52 is correct. Explain to everybody how you got 52.
Well, that arc is going to the outside past that thing, so you take 28 and subtract it from 80 because the lines are parallel.
Alright, so you're telling me this angle right here is 28 degrees, is what you're telling me.
Yeah.
Okay. Kendrick, why is that angle 28 degrees?
Sean.
Is it a right angle?
No. Kendrick, why is it 28 degrees? Because these angles, this angle, this angle, and this angle are alternate configurations because I've got two parallel lines.
Okay.
So then what she did was she took the whole thing, it was 80, she subtracted out the 28, and that gave me 52. So let's go ahead and find angle A while we're at it. So if I add these two together, that gives me 130, and 130 from 180 is 50. Now, which side do I know? A, what is A? A is 25 miles, and I'm interested in finding B and C. Alright, Bree, set it up for me to find B.
We do B over sine of B, which is sine of 78.
Very good.
And then A, which is 25 over sine of A, which is sine of 50.
Very nice. Perfect. So let's move the sine of 78 over. So I get B equals 25 sine of 78 over sine of 50. And we're ready to punch that in. So 25 sine of 78. So control divide. 25 sine 78. Whoops. Over sine of 50. So we get 31.922. What are my units right there?
Miles.
Miles. And then what's the one minor change I need to do to be able to find side C? change 78 to 52. So I go back, and I change 78 to 52. Press enter. 25.716. Okay, make sure your answers are reasonable, Bobby.
Why is angle C 52?
Because you see these arrows right here. What do they mean? What do they tell me about these lines? They're parallel. And since they're parallel, and I have a, does anybody remember what this thing is called?
Transversal.
Transversal. Since I have a transversal, that means these alternate interior angles right here are the same. So this is 28, which means this is 28. This whole thing up here is 80. So if that whole thing is 80 and this is 28, I subtract the two to get the inside. So if I subtract the two, I get 52. Alright, so angle B is the largest, which is 78, so that means side B needs to be the largest as well. Is it the largest? Yes. My smallest angle is angle A, which is 50. Its side is 25. Is that the smallest side? Yes, so that means my answers are at least reasonable. And that is law of sines to solve an oblique triangle. Reagan, what's an oblique triangle again?
It's right now. It doesn't have a 90-degree.
Triangle that does not have a 90-degree angle. Very good. Okay, and all you gotta do is make sure you match a side with its angle. A side on top of its angle, set up a ratio, solve for the missing piece. That's all there is to solving or using law of sines to solve an oblique triangle. Alright, on page 298, we're gonna do 1 through 6 all, and then number 56. Just a second. So 1 through 6 all, and number 56.